Hello everybody, this is Mr. Lakin. It is 2:06 on the clock, which means I'm a little bit tired, but have no fear. I had a Pop-Tart to keep me awake. So I am ready to go. Let's do it. Consider the differential equation dy dx equals x squared times y minus 1. This is page 17 in your packet, so please make sure you're on that page if you're not already. This is also a no calculator problem, so no calculator. This kind of question has been common in the past few years for a period of time, but now that AP is going to not, it's just going to be entirely different, who knows what's going to happen. So let's just do the problem and see what we can do. It says, consider the differential equation dy dx equals x squared times y minus 1. Sketch the slope field. Okay, well, first thing I notice, I need to put the slope of the original function based on the derivative at every single point, all 3, 5, all 15 points, all 12 points. Okay, so first thing I notice is that when x equals 0, y prime equals 0. Right? When x equals 0 here, it doesn't matter what y is, the slope is 0. So anywhere x equals 0, that's going to be this line, y equals 0. Okay, that's number 1. Number 2, when x equals 1, well, actually, when y equals 1, that's going to be nice. When y equals 1, 1 minus 1 is 0 times whatever x is, doesn't matter. Y prime equals 0 again. So when y equals 1, we have slopes of 0 as well. Next, what I'm going to do is I'm just going to plug in the last 4 points. So let's go plug in 1, 0, 1 for x, 0 for y. It looks like y prime is going to be negative 1. Negative 1 slope is going to look something like this. Let's do negative 1, 0 there as well. Negative 1, 0 means negative 1 squared is 1 again. Which means it's just going to be 0 minus 1, which is negative 1 again. So here we go, negative 1. All right. Let's go and do the next one. Let's go and do, let's just do 1, 2. 1, 2. So I plug in 1 and 2 here. Notice that this x value is really not doing anything anymore because whenever I put in 1 or negative 1, it really just depends on what y is, which makes my life a little bit easier. So when I plug in 1, 2, I just get a slope of 1. The slope of 1 is going to be kind of like this. Let's get rid of these little marks here, because those don't really count. And that means that the slope of negative 1, now I'm just checking my work to make sure I did the right thing here. I think I did. When I do negative 1, we get still the same thing. You can double check the work there. I'm pretty sure that that's right. God, I hope that's right. Negative 1 squared is 1, 2, yeah, that's right. Okay, and now when I plug in the 3, so now let's plug in 3 here and see what we get. Plug in 1, 3, my slope ends up being 2. Okay, so now I got here for this one. Okay, so 2. And I believe the same thing happens when I plug in negative 1, 3. You're welcome to check me if you think I'm wrong. I'm not wrong. It's 2 in the morning. That's my prime time for math time. Okay, that's your slope field. That's part A. Easiest points. I don't know if you're going to be able to do that on the test now. B, write the slope field. While the slope field is drawn at 12 points, it is defined at every point in the xy plane. Describe all points in the xy plane for where the slopes are positive. Holy moly guacamole, Batman. Now that's a little bit tougher. So let's take B down here. It's a dy dx equals x squared parentheses y minus 1. Now it says while the slope is defined at every point in the xy plane, meaning that there were no undefined points on the no undefined slopes at any point on the xy plane, it does say describe all points in the xy plane where the slopes are positive. Well, if the slope is positive, that means that this value has to be positive. And I know you know that this number is always positive. So really, the whole problem just hinges on y minus 1 being positive. And again, this is for part B. So if y minus 1 needs to be positive, we can say y minus 1 needs to be greater than 0. Do you like my hand? Hello. the camera is right down here instead of up here, which who knows why they did that one. But anyway, so y minus 1 is positive, which now means that if I add that 1 over, guess what? That means that any y value greater than 1 does not matter what the x value is. As long as you are above this line, your slopes will always be positive. And that suffices for the question. So, describe all points. It's all points where y is greater than 1. Let's go to C. Let's draw a line here, C. Okay, now this one, love it. Particular solution to the differential equation with initial condition. We got this. Okay, let's do dy dx. This is the separate and integrate. That's what we have to do here. Separate and integrate. Separate and integrate. That means that this y minus 1 is going to boink over here. This dx is going to doink over there. All right. And the way we're getting this y minus 1 over there is with division. And dx is going over there sort of with multiplication. So now what we're going to get 1 over y minus 1 dy. Y equals x squared dx. And now we are going to, so our variables are separated. All y is on the left side, all x is on the right side. So now let's go and integrate this thing, bye-bye. And we end up getting out x cubed over 3 plus c. On the other side, I'm going to leave it to you to try to figure this one out. So the natural log absolute value of y minus 1. I'm not going to do a u sub there because we technically don't need it. And I'll leave you to try to figure out why that is. Okay, next, I need to use the initial condition to get the particular solution. Initial condition to get the particular solution. Initial condition to get the particular solution. Initial condition to get. My wife is actually waiting for me right now because my daughter climbed into our bed. Because sometimes when I'm not there, she just likes to lie in our bed. And I think she's like kicking my wife in the back while she's sleeping. So I need to hurry up. Oh, I'm tired. But I can do it. Let's do it. Let's do it. Okay, so now what we're going to do is we're going to plug in 0, 3. 0 for x, 3 for y. If I plug in 0 for x, well, then I just get c on this side. If I plug in 3 for y, I get the natural log of 2. Well, that's groovy. That means that my c value is the natural log of 2. So now let's rewrite the equation. Natural log absolute value of y minus 1 equals x cubed over 3. Sure hope I don't have a mistake. That's natural log of 2. Alright, next we need a powerful mathematical tool called exponentiation. Get it? Powerful because it makes a power out of everything that you had. Oh, Mr. Lincoln. Oh, you're so funny, Mr. Lincoln. I miss you. Okay, so y minus 1, absolute value of y minus 1 is equal to e to the x cubed over 3 plus natural log of 2. Now, this is this little side here is an old property that you've learned, where if you have, and I'm just going to refresh your memory here, where you have a to the b times a to the c, it equals a to the b plus c, and vice versa. And we have that here. When we have adding in the exponent, we can break this up into 2 parts. So we can have e to the natural log of 2. But guess what? E to the natural log cancels out. And you're just left with 2 in the front. So all this to say that we can now rewrite this as absolute value of y minus 1. We'll drop those in just a second. Those absolute value bars. Absolute value of y minus 1 equals 2e to the x cubed over 3. Alright. Now, I need to see if I have to drop the absolute value. Well, first I'm going to drop it anyway. I'm going to get y equals, when I add that 1 over 1, plus 2e to the x cubed over 3. Alright, that's good and good. But I need to know if it was supposed to be a plus or a minus 2. Because again, when I drop that absolute value, this 2 could be plus or minus. So let's see which one it is, plus or minus. The way I find out is I plug in my initial condition again. If I plug in 0, 3, 0 for here, 3 for there, I need to get a 3 out. So 0 cubed over 3 is 0, e to the 0 is 1, 2 times 1 is 2, and I would need a plus 2, a 1 plus 2 to get the 3, which means that my answer is not a minus, it's a positive 1. And that's my answer. Y equals 1 plus 2 e to the x cubed over 3. And thank you for watching. Go to sleep. Good night. Don't go to sleep now, though. Go to sleep at normal times. Bye-bye. And technical difficulties. Oh, this is embarrassing. Okay, please end. All right, I would like to end now. Thank you. Please end. Yes, I see the recorder.